everyone, Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. So today we are going to continue our lesson in chapter 5, Network in Graph Theory. We will focus on the learning standard 5.1.2, which is compare and contrast. First one is about the directed graph and undirected graph, and secondly, weighted graph and unweighted graph. So, we are going to learn about, firstly, number one is directed graph. So, what is a directed graph? Directed graph actually is a graph with a direction assigned to the edge connecting two vertices. And secondly, we are going to learn about undirected graph. So what is undirected graph? Undirected graph is a graph without any direction being assigned. Okay, what is a directed graph? What is the definition of a directed graph? Actually, a directed graph is a graph in which a direction is assigned to the edge connecting two vertices. And directed graphs are usually used to represent the flow of a certain process. For example, we have roadmap, airline networks, electrical circuit, as you can see, computer networks, and organization charts. Now let's take a look about a simple directed graph. As you can see in diagram 1, we have a simple directed graph. So based on the directions of the arrows, it can be seen that for edge AB, A is called the initial vertex and B is known as the terminal vertex. And for edge CB, C is the initial vertex where the arrow comes out from the point C, and B is known as the terminal vertex where we have arrow going into the vertex. And all the vertices are connected in one direction only. So this is what we call a simple directed graph with all the three properties here. As you can see in diagram 2, we have a directed graph with a loop and multiple edges. In diagram 2, as you can see, it shows a directed graph with a loop and multiple edges. Based on the direction on the arrows, it can be seen that we have edge labeled with E4. And each E4 can be written as a coordinate form where we put a bracket, capital P, comma R, and close the bracket. So, E4 shows that we have vertex P where the arrow comes out, going out, and is known as the initial vertex. And point R is known as the terminal vertex because the arrow is going into vertex R. And for E5, it can also be written as coordinate form as R, P, where we have R is the initial vertex and P is the terminal vertex, where the arrow is going into vertex P. And the same thing for E2. H, which is labeled as E2, is also also can be written in coordinate form, which is Q, Q. Why we have the same letter here? Because we have a loop where Q is the initial vertex and also the terminal vertex. So bear in your mind, for any loop, it can be written as the same letter twice, because the same letter can be the initial vertex and the terminal vertex, where the arrow can coming out and going into the same letter. Okay, how about D in and D out? So if we write D in bracket capital A, means we are write the number of edges which is going into vertex A. And if we write D out bracket capital A, means the number of edges which is coming out from vertex A. What about undirected graph? An undirected graph actually a simple graph, or a graph with loops and multiple edges as drawn without any direction being assigned. As you can see in the diagram, there is no direction or arrow being assigned. So this is what we call an undirected graph. Okay, so this is the difference between directed and undirected graph. It's very simple. As you can see here from the table, as you have learned, directed graph is a graph with edges connecting two vertices marked with direction. But for undirected graph, we can have only a graph which is without any direction. So there is no arrow put in the undirected graph. Secondly, for directed graph, it has in and out direction. Depends on the arrow direction. But for undirected graph, we don't have any arrow, so without any direction. Let's take a look at the example. Okay, you are required to draw a directed graph based on the given information. You are given set B consists of vertices P, Q, R, S, T, and U. And you are also given set E consists of a pair of vertices PQ, PR, RQ, SR, SQ, and ST. Each pair, for example, PQ means the first letter P represents an initial vertex. And the second letter Q represents the terminal vertex. So, the edge will coming out from P and going into Q. So let's take a look at the solution given. Okay, so vertex pair, one by one, refer to the vertex pair. Let's say we have PQ. That means the direction is from P to Q. PR means the direction is from P to R. So based on the example, we have two edges from vertex P. How about RQ? RQ means the direction is from R. The direction is from R to Q. So there is only one edge from vertex R. How about SR, SQ, and ST? So S to R, S to Q, and S to T. That means we have three edges from vertex S. And as you can see, vertex T only connected to vertex S. So this is the directed graph based on the information given. So So as you can see, we have one point here, point U, which is appear in set V, but not in set E. This means vertex U is not connected to any other vertices in the graph, and it is known as an isolated vertex. Okay, next example. Example B. For B, we have a loop at vertex Q, and RS is a multiple edge such that D in P is 1, D out P is also 1, D in Q is 3, D out Q is 2, D in R is 0, D out R is 3, D in S is 3, and D out S is 1. So how to draw the directed graph with a loop and multiple edges based on the informations given? We just follow all the steps here. Okay, step number 1, mark all the 4 vertices as given in the example. So based on the example, we have 4 vertices. What are the vertices? We have vertex P, Q, R, and S. So you can mark all the vertices up to you at any position, but make sure in ascending order, either clockwise or anti-clockwise. Next, refer to the informations given. We are going to draw a loop and a multiple edges. So draw a loop first at vertex Q, and then draw a multiple edge at RS. Okay, next, we will complete the directed graph based on the number of edges going into and coming out from each vertex. So refer to the informations given and draw all the edges with arrow. Okay, now we already have a directed graph. Actually, we have an alternative method how to draw a directed graph. This technique is known as technique Dodi. Actually, this technique will help you to draw a directed graph easier, step by step, and it can reduce the mistakes. Okay, now let's take a look at the example here. We are going to use technique Dodi to draw a directed graph. So we have a loop at vertex Q, and RS is a multiple edges. Okay, remember that D in means degree going into, and do or D out means degree coming out. So the first step, we have to construct the table consists of do and D. Do for D out, degree coming out. D for D in, degree going into. So based on the example, we have D in P, 1. So we write letter P at the column D in. 1 letter P. D out P is also 1. So write letter P at the column D out, 1 letter. Next, we have D in Q, 3. So at the column D in, write 3 letter Q. Next, we have D out Q2. So write letter Q twice at the column D out. Next, we have information D and R is 0. So we don't have to write letter R at the column D in because it's 0. Next, we have D out R 3. So write letter R 3 times at column D out. Next, we have information D in as 3. So you have to write down letter S 3 times at the column D in. And lastly, D out as equal to 1. So write down letter S once at column D out. After we write all the letters by completing the table, the next step, we will plot all the required vertices. As you know, at a loop, it has D out and D in simultaneously because at any loop, the point Q can be a terminal and at the same time the initial vertex. So there will be 2 arrows at vertex Q, which is coming out and going into. So we will cancel letter Q, one from column D out and one from column D in. Alright? Okay, the next step, we are going to draw another edge, which is multiple edge. Where is the multiple edge? We have at RS. So draw the multiple edge at RS first without any arrow. Okay, now let's consider the letter from the table one by one. Okay, now we are going to draw an edge from S to P. So, we have an arrow coming out from S. So, we have S, D out and going into P, which is D into P. So, we have to cancel letter S, which is D out, and letter P, which is D in. Okay. Let's draw another edge from P to Q. That means you have to cancel at the table letter P, which is D out, and letter Q, which is D in. Alright? The next step, we are going to draw another edge from Q to S. So from the table, cancel letter Q at D out and letter S at D in. Alright? So now, we are going to draw another edge from R to Q. That means R is D out, cancel D out, and Q D in. Okay, now we have 4 more letters, which is R. Okay, now we have 4 more letters left. RR, D out, and SS, D in. So, we are going to complete the arrow at the multiple edge. As you can see from the table, RR is D out. So, we will draw the arrow going out from R. Going out from R, 2 arrows. So, we cancel the two letter R, D out, and the arrow going into S. Both arrow going into S, which is D in and S. So we cancel the two S at the column D in. Okay, so now we have a complete directed graph. Okay, let's try. By using technique Dode, try to draw a directed graph based on the informations given. You are given a loop at vertex Q and a loop at vertex S. You have QS as a multiple edges and D in and D out as given. Let's try it now. Let's check the answer. Is that correct, your directed graph? Let's check with the given answer.
Hi, let's play a game.
Next, we are going to learn about weighted graph and unweighted graph. Actually, what is weighted graph? Weighted graph is a graph associated with a value or a weight. Whereas unweighted graph is a graph which is not associated with a value or a weight. Let's take a look in details what is weighted graph. So weighted graph actually is a directed graph, and it can also be an undirected graph associated with a value or a weight. I repeat, the graph is associated with a value or. You can see in the example, we have a graph with an arrow and a value or a weight. So this is an example of directed weighted graph. What are the differences between weighted graph and unweighted graph? The first one is about the type of graph. For weighted graph, we can have directed graph and undirected graph. And the same thing for unweighted graph, you can also have directed graph and undirected graph. How about the age? For weighted graph, How about the age? For weighted graph, it's associated with a value or a weight. It can be a distance, a price, cost, or any other value. But for unweighted graph, it's not associated with a value or a weight. What about the example of weighted graph? So the age represents distance between two cities, or traveling time, the current in an electrical circuit, or cost. But for unweighted graph, the age just simply relates information like job hierarchy in an organization chart, floor mat, tree mat, and bubble mat. Okay, let's take a look at the example. We have a diagram on the right that shows one-way path that Izarul can choose for his running practice. Vertex V1 is the starting position. Starting position is at V1, and vertex V5 is the ending position as labeled in the diagram before he goes home. So you have to determine A, the shortest distance from V1 to V5, B, the longest distance from V1 to V5, and C, determine the vertices that must be passed through if the distance of the one-way run is between 1.4 km and 2.1 km. Okay, let's try to answer. This is the given diagram. we have to start from V1 and end at vertex V5. We are going to answer question A. We are going to determine the shortest distance. So, you can determine the shortest distance by referring to the value of distance given. So, as you can see here, if we move from V1 to V2, it will take 600 meters. And then we continue the movement from V2 to V5, where it takes another 500 meters. So the total distance is 1,100 meters, which is equal to 1.1 kilometer. If you compare to the another road, you will get a bigger value. If you compare to the another road, you will get a bigger value. So this is the smallest value, 1.1 kilometer. So this is the answer for the shortest distance. Take a look, question B. We are going to determine the longest distance. So you have to choose the route from the diagram which can give us the longest value of distance. So if you move from V1 to V2, next we go to V3, V4 and finally end at V5, so it will take 2,500 meters, which is equivalent to 2.5 kilometers. So it shows that this is the maximum value of distance. So this is the longest distance. Okay, now how about question C? From question C, we have to determine the vertices that must be passed through if the distance of the one we run is between 1.4 kilometer and 2.1 kilometer. So refer to the diagram so we can check with the value. If we choose the route from V1 to V3, followed by V4 and end at V5, so you will have a value of distance 500 plus 500 plus 500, where the value is between 1.4 and 2.1 kilometer because the value is 1.5 kilometer. So we already have the first answer. Secondly, if you follow the route, start from V1, move to V2, followed by V4 and end at V5, it will give us the value 600 plus 800 plus 500, which is equal to 1.9 kilometer. Now we have another answer, which is between 1.4 kilometer and 2.1 kilometer. So, what is the answer for question C? So we have two possible answers, V1, V3, V4, V5, and the other one is V1, V2, V4, and V5. So this is the answer for question C.
Hi, let's play another game.